So the pattern that we saw in exercise 4, this idea of 0.8 going down in terms of the power and 0.2 growing in terms of powers, even the number out in front, gives rise to a distribution called the binomial. So the binomial distribution is one that comes up whenever we are counting up a number of successes. So in this case, we are counting up the number of correct answers. We do have some requirements for this binomial that you should double check to make sure you're actually in the situation. B is binary outcomes. So for our example that we just did, success was getting the question correct, and failure was getting the question incorrect, right? Independent. In this case, independent means that one outcome doesn't influence the next. So we had a bunch of trials, right? Each question was its own trial. How do we know this was independent in our example? Because he was guessing. So since he was guessing, there was no reason that if he got one question right, it would influence the next question, because it's just complete luck of the draw, right? We need a fixed number of trials. So in this case, we were looking at 4 different questions. This would be different if you were like, you could keep doing problems until you got something right, or you kept doing problems until you got one wrong. In that case, we wouldn't know exactly how many it took. But in this case, we had a set number of 4. And our last thing is that we need our success to stay the same. And so this success to stay the same is all about what the probability is for each value. So our probability of something being correct, or our probability of success, was 20%. Or our probability of failure was 80%. And that was the same for every single question. Now, how this would have been different is if, my test, sometimes I have 4 multiple choice answers, sometimes I have 5. So this would not always be the same, and therefore we couldn't use the binomial. But these are your requirements. A nice little acronym for them for the binomial is BINS. And this is the first thing you have to do on the worksheet, is verify that all these things are met. So you're going to do something very similar to what I did here. Binary outcome, success equals, failure equals, independent, yes, n is equal to, all these different pieces. So our notation, we've already seen some of it, right? We have our n, which is our number of trials or observations. If we're talking about observations, a lot of times this will come down to a sample size. But if we're doing something random like flipping coins or guessing at questions, then we're talking about number of trials. P is our probability of success, Q is our probability of failure, and X is our random variable, which is going to be the number of successes. So if all the bins are followed, we can use this shorthand notation. This basically says X follows a binomial experiment with N trials and P probability of success. This is a statistician's shorthand to write that entire sentence. Finding probabilities from the binomial is exactly what we saw in that previous example. We're going to have, let's just look at that probability that X was equal to 2, right? 2 questions correct. When we did this, we actually counted out the 6 different ways. We had 2 successes and 2 failures. This was our final probability, right, before we did the actual calculation. So just to see this for our example, I'll rewrite. We had n of 4, p was 0.2, q was 0.8. So we're going to plug on into this formula. So the probability that x is equal to 2 is n for shoes. That's what that big SC means, and we'll talk about that in a second. Our k is 2. We'll come back to this. P, which is our 0.2, is going to be raised to the k power. And q, which was our 0.8, is going to be raised to the n minus k, 4 minus 2 power. So you can already see the back half of this matches entirely. The only piece that we need to play around with a little bit is this choosing piece, the combinations formula. So there is a mathy way to do this with factorials. A factorial, if you really wanted to do this mathily, this 4 factorial all over 2 factorial, 4 minus 2 factorial. Factorial just means 4 times 3 times 2 times 1. So whatever the value is, multiply it up until you get to 1. So 2 is going to be 2 times 1, and 2 factorial again is going to be 2 times 1. So this would all, oops, I wanted red. This is all 4, and we get out 6. But how you do this in the calculator. Don't get too caught up on it. I won't even show you in the little calculator because it doesn't end up mattering. But if you want to do this in the graphing calculator, you're going to find this in the math menu. And if you are doing this by hand, which some people do if they have a different scientific, because again, I'm going to show you a way to avoid this. Oh, it's in probability. So I went to math and then over to probability. Just know that it wants you to put in a value before you put it in NCR. So you'll have to write in your 6, oh actually we had 4, your N, and then the value that you're looking for. So that'll do all that math for you. But again, no reason to do this unless you have a scientific calculator that doesn't do the binomial calculation for you, which I don't recommend having. But if you have another calculator, send me an email and I can get you a help video on that particular piece.